this video, we will be taking a look at how we can incorporate this Rive animation in a pull to refresh experience. As you can see, it's quite awesome, and as you drag, it triggers different states, and eventually it reaches its end state, which means that new data has been loaded. This animation was specifically made to showcase how you can create a pull to refresh experience using Rive. And if you are interested in how to configure an animation such as this and how the state machine is configured, then do check the videos that Michael made. In this video, we will be looking at the Rive iOS implementation. So what you need to do to basically code this kind of experience in your application that allows you to advance the animation in the correct way. Just a quick disclaimer that the code in this video tutorial was heavily inspired by the example made by Cavsoft on YouTube. So definitely go check them out. They made the initial code and they showed you how to do it in an alternative way. And the code that I used is modified to make it work with Rive. But for the most part, it is very similar. And I'll do my best to explain exactly how this is configured. So let's actually just jump into it. For the most part, we will be focusing on the Rive implementation side of things. This won't be a SwiftUI tutorial. And I do recommend that if you are completely new to Rive on iOS, then please read our documentation on how to use our runtime on iOS and macOS. There are a variety of different examples that you can take a look at, and the documentation does a good job at explaining a variety of different things that you can do with the runtime. So with that out of the way, let's actually just jump into the code. To start off with, here we have our main window group scene, and as you can see, we call content view. So this is what you would normally get if you start a new SwiftUI project. And as you can see in the content view, here we are showing the Rive pull to refresh view. And this is a custom view that we'll be taking a look at in a moment. This is the view that we made to create the pull to refresh experience. And then within this view, you can provide content. And the content that we're providing is this mock list tile. And the mock list tile is exactly what the name suggests. It's just a mock tile. It's basically this green square over here, just to have something UI related that looks like a list. So let's now jump into the Rive pull to refresh view. Before we do that, I just noticed that there's also on refresh, and this on refresh callback is the place that you would do your logic. So we can actually just make a note over here and say to do complete some future. So this is where you will get new data or whatever. The source code for all of this will be on GitHub, so you can also take a look at this in your own time. Okay, so jumping into the pull to refresh view, this is where all of the logic takes place. And as you can see, we have a new import, and that is the import Rive runtime. And you can import Rive runtime using, let's see, add package. So using a Swift Package Manager, if you just go and search for Rive, you will find it over here. And this is actually not the correct one. This is a branch that I was using for testing. If you want to get the correct one, you can go over to GitHub, Rive app, Rive iOS, and just search for that. And here you should see the correct one, Rive app, Rive iOS. And just add this package. And I've already added that. So once you've done that, it should work. And next up, what we'll take a look at is the Rive view model. So this is the part that we configure what Rive animation we want to display. And as you can see, we create a Rive view model, which is a state object, and we need to specify the file name. And the file name is exactly that. That is the name of the Rive file. So if we jump back into Rive, you can see in the editor, we have the option to go over to share, download, and then we can download the file for our runtime. I've already done that. And once you have the .ref file, you can just go into your animations directory. Here I named it animations. You can name this whatever you want to. But I created this folder and I added it to the project. And as you can see, you don't need to specify .riv, which is the extension for Rive files. You can just specify the name. And then you'll note that we have this fit over here. And we'll go over this in a bit more detail, but essentially there are a number of different options: contain, cover, fill, fit, height, fit, width, and these do exactly what the names imply. Cover would make sure that the Rive animation fills all of the available size that is possible to fill in the most optimal way. So what does that mean? It means that if the animation or if the window that it's in or the view has a very large height but a narrow width, then it would fit the animation to fill up all the height, and you'd be cutting out some of the width. And that is exactly what we want in this scenario, because we want to ensure that the animation fills all of the available space in a most optimal way. And it will make a bit more sense once we delve into more of the code. And then we have this autoplay false. Okay, so that is the configuration for Rive. And at this point, you would be able to just display your Rive animation. So as an example, if we were to take out all of the content that we had, I believe it's there. Let's remove this, and we can just say Rive view model dot view. If we save and run this, you can see the animation is now displaying over the full view. However, it's not animating. And the reason for that is because we have autoplay false. If we make autoplay true and just run this, now it is animating. It looks different, and it doesn't seem to be fitting correctly. And that is where we come back to this cover attribute. As I mentioned, it will fit the entire height. The height is more than the width. If we wanted to say fit width as an alternative and play again, you'll see that now it fits correctly. And this is the exact state of the animation you'll note when we play it in the Rive editor. So when we press play, it's the exact same. And what we want to do is we want to take the number simulation state machine, and we want to drive that animation value. So you'll see that there's two inputs defined. There's a pull and an advance. And the pull is supposed to simulate the pull percentage of the pull action, I guess. So how far you've pulled. Once it reaches a value above 100, it goes into the strained loop phase. And what this means is it's essentially now pulled enough so that once you release the pull to refresh action, it should trigger some refresh. And once you do that, the next state should be triggered by firing the advance input. And that is now the loading state. And then once it is finished, you want it in the complete state. And now the animation will be hidden. And that is the explanation for the animation. And as you'll note, if we remove this now, let's just undo everything and play again. That is the exact behavior that we have. Once we reach a certain threshold, you'll see that now it is vibrating and it's ready. Once we let go now, it should now go into the next state. Data is loading. And now data is loaded. We wait a little bit and then close the animation or the refresh view. And that is the explanation for how the animation works. And depending on the type of experience you want to build, the state machine might look entirely different. And that's something you'll need to account for. Maybe you'd be configuring it slightly differently depending on your use case. But there's a lot of possibilities you can do. And in this example, all we need are those two inputs, a number input and the advance input. And the next step for us to understand is how do you drive these values? We see that we have this Rive view model, and we see we can display it by calling .view on that model. And the next step is to understand how these inputs are set. So you'll see that here we have the Rive view model.view. This is where we display it. And we only display this view if our scroll delegate's progress is bigger than 0. And we'll discuss the scroll delegate a bit more. That is the custom logic this app has to implement to do a pull to refresh behavior in such a custom way. We'll explore that in a moment. But before we do that, let's continue with Rive view model. So here we're displaying the view, and we'll get back to this section in a moment. The next step is for us to actually advance the view. You'll see we have the set input and we set the pull value, and we set that equal to this input value over here. And this input value is going to be a value between 0 and 100, and it will be triggered as we do the pull to refresh action. And you'll see that this is within this callback over here, which is provides us the offset. And we'll take a look at this integration in a moment. I just want to continue with the Rive view model. If we jump to the next place that we're using it, you'll see we have this reset action. And what reset does is once the scroll progress is back at 0 and this is eligible as false, we'll explore this too, we set the view model back to its default state. So to sum this up, essentially once the whole action completes, reset will be called. And the next place we use this is in the trigger advance. Okay, and the trigger advance is, just to remind you, is this trigger over here. And that's what advances the animation to different states. And we do this within the onChange event that listens to an is refreshing action. Okay, so that is how we drive our Rive animation. And now we just need to explore the code that is actually triggering these different state behaviors. One thing to note is that in this final task, you'll see that we are actually doing the trigger input twice. If we jump to the next instance, trigger input advance, and you'll see that it's just waiting for the on refresh to finish. And the on refresh is the callback that we can specify within the content view over here. So we are waiting 3 seconds. Once that finishes, then finally we actually continue with the animation. And now I just lost that space. Here we can see a wait on refresh, and then we trigger another one. And that is just to drive the animation again. Okay, so now that we have the core concepts of how we would use Rive on the iOS runtime, let's see what this custom scroll behavior does for us. We can start with the view, and you can note that we have a normal scroll view. We are scrolling vertically, and we're showing indicators. And the show indicator flag over here, if we jump to this definition, here we can specify whether we want to show the indicator yes or no. By default, I'm setting it to false. And that is because we don't want to show the indicator, we want to actually show our custom animation. And the content that we're scrolling is going to be a combination of 2 different things. It's going to be our Rive animation that is defined here, and it's going to be defined by this content that we passed in. And the content, just to remind you, is within this content view. It's going to be this VStack, and we provide the content over here. So when do we want to show the Rive animation? Well, we definitely only want to show it once we start dragging, as we mentioned before. And that is what the scroll delegate progress gives us. If we were to print the value of this progress, you would see it's a value between 0 and 1. And it is given to us by the scroll delegate over here. And if we jump to the scroll delegate, so let's jump to that definition, you can see it's a state object and it's scroll view model. And the scroll view model is a custom class we made for this example. Here we have it, that implements NS objects, observable objects, and UI gesture recognizer delegate. And for the observable object, we are publishing a few different values. Is eligible, is refreshing, the value of the scroll offset, the content offset, and the progress. And I'll let you explore this in your own time. But these different values are what is allowing us to determine the current state of the pull to refresh, how much has it been pulled down, and the progress of the pull to refresh. Importantly, within this class, we are also using the UI gesture recognizer delegate. And what this allows us to do is it allows us to add gestures and remove a gesture. And additionally, it also allows us to determine once the user has let go of the touch interaction. As you can see, we have this on gesture change, and this will get called when the gesture attribute changes. So what do I mean by that? I mean, if we start dragging and we let go, you can see the state should be cancelled or the state should be ended. And we care about these events because once this happens, we want to set the eligibility of the scroll to refresh to true or false. And what this means is that if we start pulling and we let go, if the scroll offset is less than the height that we specify, then it should be false. If it is more than the height, we want it to be true. Because if it isn't more than the height, it should go back to its previous state. And if it's more than the height specified, then it means it's eligible. Now it is, and you can see it's triggering that state. And now when we let go, it should actually start the refresh action. And in a similar way, that is how we are driving the logic for most of the pull to refresh experience. These are the values that we care about to determine the current state. So if we now jump back into our code, you can see that we have this offset over here. And this offset is also a custom implementation. So this is a view builder or a view. And what this allows us to do is determine how far we have pulled down the current refresh action. And we're doing this with coordinate spaces. And we have this callback that gives the offset of the current coordinate space. So we're using a geometry reader to get the location or the current frame geometry, and using a preference key over here, which we called offset key, to just have a nice little callback so that we can call the offset and specify the value that has changed. And in my opinion, coming from different languages, this feels like a little bit of a hack to do this, but it does work out nicely. The preference and the on-preference change for the offset keys or preference keys is a way for you to pass information from a child to a parent. But in this instance, we are just passing it directly to each other, and it allows us to just trigger the callback providing the value. The value that we are providing is the minimum height of the coordinate space using this geometry reader. So what does this all equate to? It means that if we take a look at the example again, as we pull down, maybe the offset is 10 because the frame height or the geometry reader has a minimum height of 10. Now it is 20, now it is 30, now it's 40. You get the idea. So as you pull it down, and eventually it will reach a point where different conditions will be triggered in the view model that we explored. And just for clarity, the preference key that we use is called an offset key, and here we create it over here. Please see the Apple documentation for additional information on how geometry reader and preference keys work. But all of this essentially just equates to we want the value of the size that we're pulling down. So once we get the value of that size, we get that over here where we add the view. Sorry, it's a little bit more up. So here where we add this modifier for the offset, as you can see, we have this coordinate space, which is a named coordinate space, and we named it as scroll, and we do that here as well, the coordinate space. So essentially, we just care about two views. We don't care about the global coordinate space. We care about it in relation to its parent view. And all of that is done just to get this offset value. And once we have this offset value, we can set the content offset within our scroll delegate. And each time we set the content offset over here, we do calculations to determine what the scroll offset and the progress offset should be as well. So if we continue exploring the code, you can see that we do checks to see if we are eligible. And if we are eligible, or if we're not eligible, we determine what the progress is. And that's going to be a factor that is determined based on the offset and the max height that we set. And we clamp that value so that it's not smaller than 0 and that it's not bigger than 1. And then finally, we set the scroll offset and we set the scroll progress on the scroll delegate. And that is how we determine what the value should be for our pull action, or our set input that sets the pull value for our Rive state machine. And if you're following along, you may be confused. Why are we not using the progress? Because essentially the progress should be a value between 0 and 1. Why not do progress times 100%? And just to illustrate it, we're actually going to do that. Why is this not working? Okay, progress is not in scope. Okay, that makes sense. We'll do scroll delegate.progress. So let's play that. And now if we pull down, you'll see that it's pulling down, but it's not going into that state where it's ready to fire. If we let go, nothing happens. And the reason for that is because this animation is configured in such a way that it will only trigger or allow advance once the pull is above 100. I guess it could have been configured to just be 100, but in this instance, it should be a little bit above 100. If we press advance, nothing happens. Only once you reach 100 and above, then you can press advance. And I just pressed it a little bit too fast, so it did both states transitions. So let's stop this animation. And essentially, that is why this won't work. It will only go up to 100 because we are clamping this value. So let's just undo our code. And what this allows is it just sets the value between 0 and however much you've scrolled. So eventually this will maybe be like 140 or, however much you scroll, but it doesn't matter for the state machine. We just want it to be above 100. So now we're above 100 and the animation can continue. And then eventually it will finish. And I do believe that's kind of the majority of what we need to understand with this code base. You'll see that we also set on appear and on disappear by adding and removing gestures on the scroll delegates. And the final thing is this onChange callback. So whether we are refreshing or not. So there's some logic that will set the is refreshing to true once it reaches a certain state and once we let go, once the progress is more than 100. And this onChange is just a nice convenient way for us to get that trigger, and we get the value that it is refreshing or not. And if it is refreshing, then we advance our Rive model by triggering the advance trigger. And the rest of this we did cover earlier in the video. The final thing to take note of is that once all of this finishes, we want to set everything back to its defaults. And by using the with animation, we allow the smooth scroll back for our value to just go back to the top. That is that for this video. We hope you found it helpful. The code is open source, and if you are having difficulties implementing this or implementing your own custom animation, please reach out to us